This session will be recorded, so you can look it back into in the Nestor course. In this Blackboard sessions, in the menu, you can click on the 3 stripes, and there you can find back the recorded sessions. So my name is Ilja Nolte. I am the coordinator of this course. It's actually the second time that we give this course, because in July we gave a pilot of this course. Now it's a fully registered course with the GSMS, the graduate school. And I would like to thank you for participating and joining in this course, and I hope that you will learn a lot about the UMCG high performance cluster and about the Lifelines data on this cluster and how you can use that for your own analysis. So today the topic is about an introduction to the high performance cluster, to show you how it looks like, what you can do with it. Today you will not be using any of the Lifelines data. That will be the topics of the next 2 days. So today, as I said, it's about the UMCG high performance cluster and about Linux and how to submit jobs to the cluster so that you can do your analysis on the cluster. And we have found Bob Dreugen from the Center of Information Technology from the RUG, from the University of Groningen, willing to help us as he has a lot of experience, but then on the Peregrine cluster, which is the RUG variant of the UMCG high performance cluster. And I also hope that Peter Neerings from the Genomics Coordination Center would join, but unfortunately he's still not online. So if in case he's not joining, then I will help Bob with UMCG specific parts. So with that, I would like to give the floor to Bob to introduce you to the to computer clusters and the UMCG high performance cluster. So Bob, I will share the file again for you. So that you can start. Okay.
Yeah, thank you. Good afternoon, everyone. So my name is Bob Dreugen from the Center of Information Technology. And today I will introduce you to the HPC cluster of the UMCG in this case. So usually we give this course based on the Peregrine cluster, which is the general university cluster. So most of the materials that we will be using today are based on that Peregrine course. But the UMCG course cluster is very similar to Peregrine in the sense that the job scripts and everything that you need to run jobs on that cluster are very similar to Peregrine. So most of the UMCG specific things, I hope that Ilja or Peter, when he will join, can step in and maybe tell some more about that, because I don't know all the specifics for the UMCG cluster, but again, it will be very similar. Let's see, how can I, so this is the outline of the course. So in the first part, I will tell you something about clusters in general and how to connect to clusters. So what kind of software do you need in order to connect to a cluster? How do you transfer data to and from the cluster? I will also talk a lot about Linux, because almost all the clusters in the world run on Linux. So once you're connected to a cluster, you will need some basic command line knowledge in order to run your jobs on that cluster. I will also tell something about editing files, because in order to run a job on a cluster, you basically have to write a job script. So that's a general Linux script that basically says, I want to run this step and maybe another step, and it needs this input data. So then you have to write that script as basically as a text file. After that, we will have a break, and you can work on some first set of exercises where you can practice all these commands and try to edit some files and move some files around, create some directories, etc. And then after the break, we will continue with the second part, which will be more towards clusters in specific. So I will tell something about how to use the software that's already available on these clusters, how to use the different file systems, how to actually set up a job and submit it to the cluster. And then at the end, there's another set of exercises where you can practice those topics, so you can actually try to submit the job yourself. So for this first part, I assume that you don't know anything about Linux yet, so it's fine if you've never worked with a Linux system. If you do have some experience with Linux, that will of course help, but it's not really necessary. And for most of the examples that I will show, I will assume that you use a Windows machine, but I will also show a few pointers for Linux or macOS users. Basically, if you already have a Linux system, then most of this will be you might already know these things anyway, so I will not go into too much detail for Linux and macOS. So first, a very generic overview of a cluster. This is the Peregrine cluster here located at the Duo building in Groningen. But just to show how a cluster looks like, this is basically the same for every cluster that you can think of. Because a cluster is basically just a bunch of machines. So here you see all these different cluster nodes, as we call them, which are connected by a very fast network. There's lots of storage attached to that network as well, so that you can basically access all the storage on all those machines. Now, this might sometimes be a little bit different in the sense that some storage you can access on all these machines, and for some other storage you cannot, depending on the type of storage. But in principle, there's always one type of storage that you can access across the entire cluster, so on all the different machines of that cluster. Usually there's no way for a user to just access directly access one of these cluster machines here in the back. But you will have to go through a so-called login machine or login node or a front-end node, sometimes called a user interface machine or node. But that's basically the entry point of the cluster. That's the only machine that's more or less connected to the outside world and that you can access over the internet. And those machines are not really used for running jobs on those particular machines, but you really use them as some kind of gateway to the cluster. And then on these machines, you basically prepare the jobs that you want to run. And at some point, you will submit those jobs. And then there's a special piece of software called the scheduler, which will take your job and run it on one of those machines, depending on which machine has available resources. So this is the same for both Peregrine and UMCG clusters in principle. Besides that, they might be located at different data centers, of course. So how did a cluster get invented, basically? Well, this is a picture of one of the very first clusters. And what you see is basically just a bunch of desktop computers, all connected here by a network switch in the middle. And that's just a cluster, so just a bunch of machines connected by a network. And this might look a bit weird, but basically nowadays a cluster still looks more or less like this, except that it's better organized. Don't know if the animation works here. No, you see it at the back basically. So that's a picture of a cluster, how it looks nowadays. It's just a nicely organized rack with computers which are more or less the size of a pizza box. The cabling it's much better organized than the cooling, but in principle it's just one rack with a lot of machines connected by a network. So still the idea is very similar to this very first cluster here. So how do you get access to a cluster in general? Because that works more or less the same for almost every cluster. Well, first, for the UMCG clusters, you of course need an account. Same for Peregrine. If you want to use that cluster, you first have to request access. So for the UMCG clusters, you can go to this page of the documentation, and you can request an account. And there's some particular security details for this cluster. You need a key basically to be added. Not sure if I should tell more about this because probably Peter and Ilya know more about this, but I guess everything about the UMCG cluster is explained on this webpage. So that will tell you how to get an account on those clusters. So once you have a system, there's another page on the documentation that will explain in lots of details how to set up your account. Because you have to go through a so-called jump host, which will give you access to the cluster itself. So you cannot directly access it through the internet. You have to go through a specific machine. That's another kind of security measurement in order to shield off the cluster from the internet. This requires you to set up some extra configuration in the tool that we will be using to connect to the cluster, but that's all being explained on that web page. The most important thing for now is that the connection is based on the so-called SSH protocol, and that's being used for UMCG, for Peregrine, and almost any other cluster as well. So this is a standard protocol. SSH means a secure shell, where the secure basically means that it's everything you will type in basically gets encrypted, and then it gets sent over the network, so that anyone who's listening in on the network traffic cannot see commands you're typing in or passwords you're typing in, because that's all being encrypted. If you want to use this SSH protocol, you need some specific kind of software that supports SSH. And for Windows, we will be using this tool called MobaXterm. There's another one for Windows called PuTTY. Some people are already familiar with PuTTY. If you are, then you can just use PuTTY as well. For now, I will show MobaXterm because it has a text editor built in. It has a file transfer client built in, so that you can easily upload or download files to or from the cluster. So basically, you get one tool which can do almost everything. While with PuTTY, you need some additional tools maybe for copying files. This tool, MobaXterm, you can download that for free on this website. It's freely available for personal use, so you can just download it and install it on any Windows machine that you have. So this is what MobaXterm looks like. If you start it for the first time, you basically get this screen, and you have a list of sessions here on the left, which is then still empty. So when you use it for the first time, you have to do some initial setup. That looks like this. So you have to press the, let's go back one slide. You have to press this session button first here, because you want to start a new session. Then you get this screen, and you can choose different kind of protocols. But in this case, we want to use SSH. And you have to fill in some additional details about the machine you want to connect to. So here you will have to fill in gear shifts. You have to fill in your UMCG username. And you have to fill in the path to your private key, which you have to set up first. Again, this is explained on the documentation page, how to do this in more detail. So how to set up a key, but once you've done that, you can just use it here. Then there's some more details, because as I mentioned, you cannot directly connect to the gearshift cluster. You have to go through that jump host, which is airlock.hpc.rug.nl. So at this network settings tab over here, you will have to fill in some more details. So the host name of that machine, again, your username on that machine, which is usually the same as on gearshift, and again, the path to your private key. Once you've done that, you can just press OK, and then you can more or less forget about this procedure, because the next time you will start MobaXterm, this is all saved in the session. So if I go back to that particular slide, you should see the session here on the left, and then you can just double click it. So the next time you will open MobaXterm, it will be stored in this list, and you can just double click it. So when you do that, you will basically get this screen. You will be logged into the gearshift cluster. You get this black screen over here where you can start typing commands. And on the left-hand side, you will see basically the file explorer of all the things that you will have on the gearshift cluster. So all your files and directories on gearshift will be listed here in this panel. So most of the things that you would like to do with your files, so copying and uploading, downloading, renaming files, deleting files, all of that you can do here on the left-hand side, where you can, for instance, right-click a file and start renaming it. Or, well, you can delete a file. There's some buttons here at the top. So not sure if you can see this, it's a bit small, but there's these arrow keys here basically at the top. Those are the upload and download buttons, where you can with the upload button, you can basically select the file on your own machine and upload that to the cluster. With the download file, you can select a file on the Gearshift cluster, and then it will start downloading that file from the cluster to your local PC. And something about the file organization, the differences between Windows and Linux. So if you're familiar with Windows, then you'll probably know this, that well, in Windows you first always start with a drive letter and a colon and then a backslash, and then you get folder names or file names depending on what kind of stuff you have over here. But for instance, your documents and settings thing, that's a directory or a folder, which might have subdirectories. So with your username, for instance. Then in your username folder, you might have a folder projects and project X, and etc. And then if you want to refer to this folder on a Windows machine, it will look like this. So again, drive letter, colon, and then backslash, directory name, backslash, directory name, backslash, etc. And then the last part can either be a directory name or a file name, depending on what you want to point to. So how does that look on a Linux system? It's a bit similar, but also a bit different in the sense that on Linux, you don't get drive letters. Linux just doesn't have that concept of drive letters. It basically only knows directories, and a directory can map to a specific drive in your machine, but doesn't have to. So that's all a bit hidden, because in principle, you don't really need to know about that. So you only have directory names, and those all start at the root folder, which is this thing at the top, and you can denote that root folder by just a slash. So that's basically where everything starts, and then you can think of this again as some kind of tree. So the tree starts at the root folder called slash, and then you again get lower into the tree with the directory names over here, and you just go down and separate all the directory names by a slash, and in this case it should be a forward slash. So it's just the opposite kind of slash compared to a Windows system. So if you again want to point to this particular folder, project X, just like on the last slide, now you don't start with a drive letter, you just start with that slash to denote that you're starting at the root of the file system, and then you go into home, your username, and then some directory names, all separated by forward slashes. And again, the last thing in the path can be either a directory name or a file name, depending on what you want to specify here. So to summarize those differences, in Windows, you always use this backslash to separate directory names, and you have a drive letter at the beginning. In Linux, you have a forward slash. So if you compare it to that one, it's just the different kind of slash that you have on your keyboard. And you don't have drive letters, so you just have these slashes and directory names in between. Then something about spaces. In principle, if you want to, you can use spaces in directory names or in file names on Linux. But usually I don't really recommend them, because it will give you headaches if you wanted to start typing commands and you have to provide the path to a file, for instance. So for instance, if you want to provide this path to this file name testfile.txt to some command, so you want to run some program and you want to give this as an input file, because there's a space here in the middle, the program might read this as up till this t as the first argument that you supply to the program, and then because there's a space, which is usually the separator to separate different input arguments, it might read this as the second argument that you're passing. So it might think that these are two different things separated by a space, which is not the case, because this is one path to one single file. So you might get weird errors if you just type it like that. And in order to solve it, you will have to put quotes around it. So by putting these quotes around it, you basically tell Linux this is one single argument. So ignore, or not ignore, but assume that all the spaces in this argument are part of the same path. So that will solve the issue, but well, you might forget about that one time, or you might automate things and forget about these quotes, and then at some point your script might give weird errors because you're pointing to something with a space in the file name. So in general, I would advise to just use underscores, or just get rid of the spaces in some other way and don't use them. And a final difference to keep in mind is that, in contrary to Windows, Linux is case sensitive with regards to file and directory names. So you can even have two files in the same directory with these names, so with a lowercase f and an uppercase f. But other than that, the file names are exactly the same. And that also means if you want to run a program and give one of these files as an input, you will really have to specify with the right casing which file you mean. Because if you, for instance, would type this fully lowercase, then it will just give an error saying that there's no file with a name myfile.txt completely in lowercase. So if you want to use this file, you really have to use this uppercase M. And if you want to use this one, you have to use the uppercase M and uppercase F in order to let your program find the right file. So then more specific about GearShift. Well, GearShift is a Linux system, so in principle, the same slide as the Linux slide applies to GearShift. So again, everything starts in the root folder, and then you have, for instance, a home directory, which I will come back to in a bit. But basically, on every Linux system, you have a home directory. So your home directory will look like /home/ your username, so in this case, UMCG Nolte. And then underneath that directory, you can store files or directories in your home directory. And another important one on GearShift, so there's more in the root folder on GearShift, but for most of those directories, you don't really need to be aware that there's other stuff because you don't actually have write permission to those directories. But these are the two important ones. You also have in the root folder a directory called groups, which will refer to the group directories of the groups to which you belong. So you can only access the group directories you are a member of. And then in each group, you will have different types of storage. So one for more temporary stuff and one for more permanent stuff, I think. If this is wrong, then please correct me, Peter. So in principle, you can store files in both of them, depending on the use case. And I think we will come back to that later about the particular differences between those. But for now, it's just enough to remember that if you want to go to one of these directories, you have to specify /group/ the group name / well, either this PRM or TMP thing, and then projects and the particular project name or number. So let's go to the next one. So then the home directory, already mentioned that on the previous slide, but in basically any Linux system that you will be using, you have a home directory, which you can compare to your user directory on Windows. So on Windows, you have this documents and settings, and then inside that folder, for every user of that Windows system, there's a particular folder. This is basically the same on a Linux system, but then with a home directory. And most often you will find your home directory on Linux systems in /home/ your username. So on UMCG clusters, that will probably be /home/ UMCG- and then your username. Another thing with the home directory is that basically always when you log into the system, you will start in that directory. So with Mobile Xterm, if you log in, you will always start with both the file transfer client and with the command line interface, you will start in your home directory. So by default, anything you will run will start in that home directory. And if you don't want that, then you can, of course, change to a different directory, for instance, to your group directory. And I will show you later on how to do that. But it's good to remember that you always start in that home directory. And that home directory is also important because most programs store tiny text files in that directory. For instance, if you change default settings in an application, and often they will create some kind of settings file which gets stored in your home directory. So sometimes you might see that programs start complaining because it cannot write to your home directory anymore, in case you might have exceeded your disk. And then even though you don't store data sets there, then it could be that that application just tried to generate something in your home directory which made it exceed the disk quota. So then you will have to clean up a little bit of space. And often, so especially on UMCG clusters or on Peregrine, this home directory is not intended to store large data sets. So there are separate file systems where you can store lots of data, but the home directory is a specific kind of file system which is not very suitable for storing these large data sets. So in principle, you should only store very small stuff like small text files or very small scripts in your home directory. But anything that gets more than, well, let's say, tens or a few hundreds of megabytes, you should not store them in your home directory anymore. Because often the disk quota is also quite low. So on Gearshift, there's 2 gigabytes of disk space in your home directory, and then you quickly might run out of disk space when you start storing large files. So the same applies to jobs. In principle, you can run jobs in your home directory, but again, this storage is not really intended for doing heavy processing. So it's not recommended to launch your jobs from your home directory, but you should use the group storage instead. So then the group directories. So again, I don't know all the details about this. So if I'm saying something silly, then please correct me, Peter or Ilya. But you have a group directory in /groups, and there were 2 different types of directories, which I showed on one of the previous slides. So there's this PRM, which stands for permanent data, and there are backups being made of this data. So if you store important stuff in that directory, you can be sure that there are backups. It's write protected, so I assume here that means that it's only read only on only compute nodes. Is that correct, Peter? I don't know if Peter is listening. Probably not.
Yeah, so indeed, the permanent storage for the UMCG Lifelines, we as users cannot access it. But if we have space there. But if we want to store something there, we have to ask the Lifelines data managers to put things there for you to archive.
Right. Okay. So thank you. So you cannot write anything in those directories, and you cannot run your jobs from that directory. So if you want to write stuff, I think that's on the next slide. So that's the temporary storage. So in the same path as the other one, you also have a TMP 01 directory, which is the high performance file system. So it performs really well for read and write actions, but it's only intended for temporary data. And that also means that there won't be any backups being made of those data because it's temporary data. But you can run your jobs on that file system, and you can use this for storing files. So in principle, you should always launch your jobs from this temporary directory. Then there's a releases. Hope Ilya can say something about that one as well.
Yeah, maybe I can do this one. So the releases folder, that is both on the permanent and the temporary subfolders. They contain all the Lifelines data. So it's the data on the phenotype and on the older genotyping chip that was used, the cytosnip, and also the newer UGLI data that has been released early this year. You can find those within the releases folder directory. So it's on within the permanent and within the temporary folders, and then directly releases. So you have, let me see, no, I don't. Okay, so you have here is the phenotype data, the GSA, that's the UGLI data. There's also, here is the cytosnip data. There's also data on COVID. So since March, a lot of data has been collected on COVID. In the beginning, weekly, each individuals from Lifelines who wanted to participate filled in questionnaires, and even now questionnaires are filled in. So also these data, if you want to use them, you have to ask Lifelines for access to a specific folders. So Lifelines will give you access to specific folders. So for instance, if you say, well, phenotypes you'll probably get always, but if you want to use the UGLI data or the cytosnip data or both, then there is also data on Lifelines Deep, which is more sequencing data. So all Lifelines data are stored within these releases directories.
Okay, thank you. So there's a question in the chat, I think.
Well, there was Sylvia who said that
Okay.
if you want to use the COVID data, you need an approved analysis plan from Lifelines, and that holds for actually for all the Lifelines data.
Okay. Are there any questions so far about Windows, Linux differences, or connecting to the cluster? If you have any questions during the course, then also feel free to raise your hand or just type it in the chat. If not, then I'll continue. So once you're connected to the cluster, you basically get that black screen where you can type commands. So that's basically where you need to know the Linux command line environment and the commands that you will have to type to, for instance, move files, delete files, or submit jobs. So there's a whole bunch of commands that I could explain because Linux has well, a huge number of commands that you are able to use. For now, I will just go through the most important ones because a full Linux course will take far too long. So I will just explain the most basic ones that you will often need. So this is the Linux command line interface. I might abbreviate that with the CLI on some of the slides. And that basically works by typing in commands in that black screen, where a command looks like this. So there's the name of the command, and possibly some options that you can pass to the command and arguments that you can pass to that command. So the name of the command is just, well, whatever command it is. So for instance, mkdir for creating a directory, which I will explain on the next slide, I think. But that's just the name of the thing you want to run. Then the options, sometimes this is not necessary. Sometimes you only need them in special cases where you want to do something which is non-default. So these are often some kind of flags that you can pass to the command, and they often look like this, or minus some letter, or sometimes minus minus, and then some name of a flag. For instance, minus minus ignore, or minus minus verbose, or something like that. And in many cases, you have either or you have both a short and a long version for that same particular option. So if you know the short option, you can use that one. But then it might be a bit unclear what it means. And there's often then the long version of the same option, which is more clear what it does, but also a little bit more work to type it because it's more letters you have to type. And then again, arguments that sometimes that's optional. You don't have to use them, but depending on the commands, you might have to, for instance, specify the file name of something you want to do. So if you want to remove a file, you of course have to tell the command which file you want to remove, otherwise it doesn't know what to do. So that's then the argument that you have to pass to that command. Some commands don't take any arguments, so that's just a command which does something and doesn't operate on a file, for instance. Then probably you don't have to specify an argument. Some commands operate on a single argument. For instance, removing a file, you only have to supply one file name. But there's also commands like copying, which really ask you to specify 2 arguments or even more in some cases. Because copying involves something that has to be copied and some destination of where you want to copy it to. So then you really have to specify 2 arguments. So this is an example of a command. I'm not going to explain what it does now. I will do that on the next slide when I explain mkdir. But this is just make a directory, pass in some option, which will do something specific in this case, and then pass in the name of the thing that you want to create. And in this case, we basically create 2 things, which is non-default, and that's why we have to pass in the -p. But I'll explain that in a second. For almost any Linux command, especially the default ones, you can also look up the manual page if you want to find out more about that particular command. So then you basically type man, which stands for manual, space, and then the name of the command that you want to know more about. So for instance, for mkdir, you can type man mkdir, and then you get a manual page which will list all the different options that you can pass to mkdir and what they will do. Sometimes you will find examples of how the mkdir command can be used, etc. So I will now go through, I don't know, about 5 to 10 different commands, which you almost always will need when you start using the system. And again, there are many more, but I will not explain those now. So I will try to go quickly through them. Might be a bit boring, but there's no really exciting way to explain them all, I think. So the first one is ls, which stands for list, and ls will basically just dump the list of files and directories in that current working directory where you are working at that moment to your screen. So if you just type ls, you will basically see all the files and directories in that folder. I can try to, then I have to stop sharing to show you how this works. Give me 1 second. This should do it. Yes, I'm going to go to a different window. So I'll also show you MOBA Xterm just to check. Yes, you're seeing this now. So my Windows installation here, I have my personal download of MOBA Xterm. So I can just launch it from here. So I can also show you now how MOBA Xterm works. I'm going to connect to Peregrine now, but again, Peregrine is very similar to the UMCG clusters. So I've already done this before, so in this case, I don't have to go through that whole session thing over here, but I can just double click the session that I've configured before. So now I have to type my password. I'm not going to save it here, it's not necessary. So I'm just doing this to show you how a command line interface works and looks like. So once you're connected to either Peregrine or a UMCG cluster, you will get some login message over here. Might have some news or updates or maintenance notifications or whatever. But at some point, you will just see a line which looks like this. So basically, your username, the name of the machine you're working on, and this tilde over here means I'm working in my home directory. The tilde on the Linux system refers to your home directory. It's some kind of shortcut that you can use to denote your home directory. And now I can start typing commands. So to show you what ls does, ls will basically just list all the files and directories in my home directory. You can also see that on the left here. So here I'm also in my home directory. And you might not see all the ones that you see here over here, because the ones starting with a dot basically are hidden files on Linux. So everything that starts with a dot in the file or directory name are considered to be hidden files on the Linux system. But starting from here, you basically will see all of those on the right-hand side here when I type ls. So you can just see which files and directories you have. Let's go to the slides over here, and then I can hop between the slides and the command line interface every now and then. So this was ls. You can just type ls without anything, and then it will do what I just showed. So it will show the ones in your current working directory. If you want, you can also put in a different path to a different directory, and then it will show the contents of that directory if you want to. So you can do ls/groups, for instance, to see all the different directories located at /groups. Another way of doing that is to first change to that groups directory and then do a ls over there. And changing directories, you can do that with the cd command. And then you have to provide the name of the directory or the path to the directory to which you want to change. So if you want to change to that groups directory on the UMCG cluster, you would have to type cd/groups/ and then the name of that group. So on Peregrine, it doesn't work because we don't have this groups folder, but so then I will get an error. But on the UMCG cluster, that would work. And then you can do an ls in that directory to see the things in the groups directory. But on Peregrine, I can, for instance, now go into the examples directory that I have in my home directory. Then I don't have to specify the full path, so I don't have to do this home directory username /examples. That would work, but it's a bit more typing. If the directory is located in the current working directory, so the directory I'm currently located in, which is the case in this example, I can just do cd examples, and then the system will assume that that examples directory can be found here. So what will happen, you will see that this tilde now changes to examples, because this always shows the last directory name of the path you're currently working in. So I'm now working in /home/my username /examples. but over here you can only see that I'm in a directory called example, so it doesn't tell you in details where you are, but you can get some clue of where you're working at the moment. Then there's some special concepts which you can use for CD and also for other commands. First one I want to mention is ... Basically ... means one directory up, so the parent directory of my current working directory. So in this case, this means go from the examples directory one level up, and that means I will be brought back to my home directory, because that's the parent directory of the examples directory. And I can do it again if I want. Then I go into the home, so the directory where all the home directories of all the different users can be found. And I can do it again. Then I go from home to the so-called root folder. But I can't go any further than that. That's the root of the file system, so you can't go up anymore. I can try to do it, but then you will see that nothing happens anymore. I will just stay in the root directory. Another easy one, if I want to go back to my home directory, I can of course start typing cd, home, etc. But much shorter or easier is to use this. Oh, doesn't work. Why does my tilde not work? Ah, there it is. So I can do cd tilde. That means, as I mentioned before, tilde is a shortcut for the home directory. So this means go to the home directory. But with cd, there's even a shorter version. If you just run cd without any argument, cd will assume that you want to go to your home directory. So if I just do cd enter, I'm back in my home directory. So that's everything about cd. Yeah, I forgot to mention this one. There's also cd with a single dot. So double dot means the parent directory. A single dot means the current directory, which is of course a bit stupid to use like this. So cd single dot means change into the current directory, which well, it's a bit weird because you're already in the current directory. You cannot really change to the current directory. So for cd, that doesn't make any sense, but the single dot can be very useful. For instance, if you start copying files, then you can tell the copy command, copy this file found in slash whatever, some file name, into the current working directory, and then you can just pass that dot to the cp command, which means copy it into my current working directory. Then next one, make a directory. Well, it does what the name already suggests, so mkdir, and then you have to supply the directory name that you want to create, because otherwise makedir doesn't make sense if you don't tell it what to make. So you can just do makedir and then well, whatever, my new directory or something, then it will just make that directory and well, it won't report anything. So if you don't see any message, you can assume that there was no error and the directory has been created. Now there's a trick if you want to create a directory with a subdirectory already in it. So if you want to make basically multiple levels of directories in one go, by default makedir won't do that. It will complain if you just give this data/test as an argument, because it only will make one directory at a time by default. But the -p basically means that you first want to make that parent directory and then the subdirectory in that parent directory. So if you pass in the -p flag, then you can create this leveled structure of directories in one go. Well, if you have made a directory, maybe at some point you also want to remove directories. So the opposite of mkdir is rmdir, remove directory. And again, you have to pass in a directory name of the thing you want to remove. It only works on empty directories. I will come back to a different command later, which will or which can also remove non-empty directories. And it can use the same trick if you want to remove those two directories, which should both be empty. Other than that, data only contains test, but there should be nothing else in data, and test should be empty. Then you can use rmdir -p data/test, and then it will first remove test from data, and then data should be empty after that, and then it will also remove data for you. So if you try this on a non-empty directory, then you will get an error. I can show you how that works and how an error looks like. So for instance, this examples directory, I know that it's not empty. So if I try to remove it, I will just get an error. So won't even remove anything from the directory. It will just get an error. This directory is not empty, so I'm not going to do anything. Then the copy command, that's already a bit different from the other commands, because in this case, as I mentioned before, you have to supply two arguments to the copy command, both the thing that you want to copy and the destination where you want to copy the file to. And there are some useful options. I will only explain the -r option because you might need that quite often. That's being used if you want to copy an entire directory with everything in it. So if you have a directory with lots of files or directories in it, by default you cannot use CP to copy that directory, but you have to use this -r flag, where -r stands for recursively. So that means recurse through the entire directory and just find all the files and directories in that directory and copy them all to the new destination. So some examples, because CP is a little bit different behavior depending on what you're passing to it. So I'll go through a few examples and explain you how that works. So this first one is one of the most simplest forms of CP that you can use. In this case, we say, okay, copy from the directory, and this directory should be in your current working directory. Otherwise, you have to point to the full path of that directory. So for instance, /group/ whatever. But assuming you have this directory in your current working directory, this says copy from PRM03, the file named file.txt, and copy it to my home directory, / and then you can even give it a new name right away. So this will copy the file into your home directory and rename it from file.txt to myfile.txt. So it does a copy and rename in one command. This basically does the same, so it copies the same file, but in this case we pass a directory name as the second argument. So here we use the file name as the second argument. Here we use the directory name as the second argument, which we've denoted by adding this / at the end, which is not really strictly necessary, but this is just here to indicate that this is a directory. And what it does in this case is, because you haven't supplied a new file name, it will just take the file name as it is and copy this file name with the same name into your home directory. So it won't be renamed, so the name will still be file.txt, but in this case you will have a copy in your home directory. This is very similar to the previous command, except that now we give the single dot, and as I mentioned before, this means the current working directory. So it will copy the file into wherever I'm running this command from. So if I run this in my home directory, this will basically do the same as the second command over here. If I run this in the group directory, it will copy the file into the group directory. So it really depends on where you run this command. This is a special case where you can even copy multiple files in one go. So in this case, we don't give 2 arguments as listed over here, but you can even list more than 2, so 3 or even 4 or 5. And in that case, CP assumes that all the first ones minus the last one. So in this case, the first 2 arguments are the source files that we want to copy. So we are going to copy both file1 and file2.txt from the current working directory. And then it will assume that the last thing that you specify is a directory name, because you, if you want to copy multiple things, then it can only do that by copying them all into a single directory. So you cannot say copy file1.txt and file2.txt to, for instance, file3.txt and file4.txt. Then it gets completely confused about what you want to copy where. So if you want to copy multiple things, this only works by first having a list of files and the last argument a directory, and then it will copy those files into this directory. And finally, the most well, maybe complex, or the command that does the most operations basically is with this -r, because in this case we're going to copy an entire directory, so the documents folder in this home directory. It's a bit confusing maybe because it's also going to copy it into the home directory, which is probably going to cause issues. So we basically want to copy here a directory to the same location, unless we're running this as a different user. But we can, for instance, let's change it for now to something like this. So now we're going to copy this documents folder into the home directory /docs, and then it will copy the entire directory. So every file that can be found in documents and every directory that can be found in documents will be copied to the new location. well, there's also a remove for files, of course. So if you want to remove a file, it's just rm and then the name of the file that you want to remove. And the nice thing is that you can also use this with the -r flag again, which also here stands for recursively. Then you can also use it on directories, and then it will remove directories even if they're not empty. So the simplest case is just rm some file.txt, for instance, then it will remove that text file. But you can also use it like this, remove an entire directory by doing rm -r and then the name of the directory. But there is a huge warning here. On Linux systems, you don't really have a trash bin. So if you run this on the command line, rm -r whatever, it really is going to remove that entire directory. So be sure that you pass in the right directory name here. And it can even become more dangerous if you use this asterisk, which not only works for rm, but again, you can use this in principle for lots of commands. And the asterisk basically means match anything that well, starts with whatever. So this star, basically, this asterisk means basically any pattern that you can find. But the last part of the pattern that of things that should be matched should be .txt. So what this does is remove all the files that have a .txt file extension. So basically any text file that you find in the current working directory. So if I would do that here, I can also check that first with ls. So ls takes the same kind of thing. So you can do ls star.txt. Then you can find all the files that have this pattern. So this asterisk.txt. Try to make this a bit bigger. So I hope this is better. So this is a good way to verify what our rm star.txt would do, because it I've just printed the files that will be matched by that pattern. So then you can be sure that all those files will be removed by the rm command. You can also use that star in different ways. So you can, for instance, say, well, suppose I want to remove everything that starts with a J. You do J asterisk, and then it will match basically any files with a J and then whatever pattern after that J. So in this case, that will mean this file, and this file, because and this one, because they all start with a J. To make it even more complex, you could also even do something like this. So star J star, that means find any file that has a J somewhere in its file name and remove that file. So it will basically match anything which has a J in the file name. And well, most dangerous one is just star. That means, well, match just anything. So any file with any name will be matched by this this notation. That means that it will basically remove all the files here in my home directory if I will run it from here. It won't remove the directories, because for a directory I need this -r. And if I use those in combination, so the -r in combination with the asterisk, that's one of the most dangerous commands that you can run, because now it basically says recursively remove anything with any given name. So it will go through my home directory and find any file, any directory that it can find, and those will all be matched by that asterisk, and they will just be removed. So if you're going to do something like this, be really sure that you're running the right command, because otherwise you might just remove lots of files that you don't want to remove. And as mentioned, there's no trash bin, so there's no easy way to recover from that, or there's even no way at all, unless there's a backup. Then of course you can ask the system administrators to restore files from a backup, assuming that they have been backed up already. So if you just created those files, they might not be in the backup yet, and then they're really gone, and there's no way to get them back anymore. Then one of the last one is the move command. Move is almost similar to copy, except that copy leaves the original file intact, while move will, well, as the name says, it will really move the file from here to there. So the original file will be gone after you've run this command. You can also do that just like with copy on multiple files. So in this case, move this file and this file into that directory. And just a remark, move is basically also the same thing as renaming. So if you want to rename a file, you can just move it by saying move, and then the old name of the file, and then the new name that you want to give it. So move also is rename. Then a few more, which I will go through a bit more quicker. PWD, that means print working directory. As I mentioned before, if I, for instance, go to my examples directory, you only see here that you're in a directory called examples. You don't really know where that is. So if you're lost, you can run pwd, print working directory, and that will give the full path to the directory you're currently working in. So in this case, I'm sure now where this directory is located. Then there's echo. That's not really useful to run here. I can just say echo hello, for instance, and then it will do hello. So if you have programs, for instance, before, echo is just a print function, basically, which will just print a message to the screen. That's not useful here, but once you're going to write scripts, especially if you're going to write a large script, then echo commands can be useful, especially for debugging purposes. Because if at some point your script would crash or will be killed by something, these debugging messages can help in finding out where the issue was. So if you don't put in any echo statements, then you might not have a clue where it crashed, because it just started running and after 2 days it crashed and you don't get to see anything. But if you put in some echo commands between different steps, for instance, you can put in echo commands saying starting step 1, finish step 1, starting step 2, etc. And then in the output you can see, hey, it's still printed starting step 3, but then there was no output anymore. So then you know that there was an issue in step 3. So they're quite useful in scripts, but not if you type them yourself on the command line. And Man already explained to you that's for getting help about the particular command by giving the manual page. Then a few more which operate on files. If you want to inspect the contents of a text file, you can use these 3 commands. Less will just basically show the entire contents of the file. It will give you a very simple file viewer here in your terminal. So I can try that. I don't know what there is in this file. Current. I'm in the wrong directory. So I want to open this current files.txt. Then I can use less to inspect the contents of this file. If I now press enter, I see the contents of that file. So there's apparently some directory listing in this file. And I can use the arrow keys and page up and page down to go through this file and go back to the top, etc. Once you reach the end of the file, you will see that here at the bottom left, it will say end, so I can go down any further. And then if I'm done, I can press the Q on my keyboard, so Q for quit, and then I'm back here, and the contents of that file will be gone. So it doesn't get printed here, you just get to see it, and then you can get out of that text viewer again. 2 other commands that I had on that slide were head and tail. If you're only interested in the few first lines of that text file or any other text file, you can use the head command. So head by default just prints the 10 first lines of that file, and tail does the opposite. It prints the last 10 lines of that file. You can change that with an option if you want. If you want to see the first 20 lines, for instance, you can use a -n option and provide 20, then it will print the first 20 lines of that file. So these are very useful, especially if you are going to run a job and you want to inspect the output of your job. You can use these commands to look at the text output file of your jobs. Few more tricks. Already used the first one with the last command, tab. That's for auto-completion. So if I again want to print the first 10 files of this current files.txt, what I just did was type something like CU, and then I press tab. What it will do, it will look for anything here in the current working directory which matches CU at the beginning, and it will try to autocomplete. For this file, that works, of course, because there's only one thing starting with CU here. So if I now press tab, the system will assume that I want to open this file because that's the only one starting with CU. And that saves me from typing quite a lot of letters here, and saves me from, for instance, making any stupid typos. So if I, for instance, make a typo here, and instead of the R, I will type, well, let's say the F, for instance, and now press tab, then I won't get anything because the system can't find anything starting with those letters. But with the R, it does work. Now, what happens if I, for instance, want to open one of these java.log files? There are 3 of them which have a similar file name. So if I start typing JA and then press tab, the system will know, well, you probably want to open one of those, so it will autocomplete up to the point where the names are still the same. But now it doesn't know which one of these three I want to open, so I will have to help the system by typing either a 1, a 2, or a 9. And if I don't know what to type, I can press tab twice. Then it basically shows here which options there are available at the moment. So now I know, okay, I have to, for instance, type a 1 and then press tab again, and then it will do the full auto-completion. That also directory names, for instance. So if I want to use that on my directory name, that also works, except that there might be lots of accounts with similar names. So if I now use it, I get lots of these F numbers which have a very similar account name. So then it's not really useful, but at least it will show me that I haven't made a typo, because if I make a typo somewhere here, so let's say I type A here in the middle, and now start continue typing. If I now press tab, then I don't get anything anymore, even if I press it twice. And then I can be sure that there's a typo, because the system doesn't understand what I'm typing anymore. So then, if you don't get any options anymore, you can be sure that you made a typo here in the directory path. Let's go back to the slide. What else do we have? The up and arrow keys. That can also be useful, because you're typing lots of commands, and at some point you might want to repeat the same command or repeat it in a slightly different way. You can press the arrow up key to go back to the last commands that I've run. So by doing that multiple times, you will see all these different commands that I've run today and even before today, because it will store the last, I'm not completely sure, but I think a few hundred commands, the last few hundred commands that you've run. So you can go back quite far and run all those commands that you've run before again. And suppose at some point I find the right command that I want to run, I can change it a little bit if I want, and then just press enter, and it will rerun that command for me. I can also go back with arrow down, then I go back the other way again until I'm back at where I was at the moment. So also very useful to use if you want to repeat something. Then there's Control-C. Control-C is not copy, unfortunately. That can be very confusing when you start using MobaXterm. But Control-C on a Linux system basically means cancel. And it can be useful if you're running a command here which takes too long to finish. Then you can abort it by using Control-C. Most of these commands that I've shown so far, like ls, those finish instantly. So there's no useful way to use Control-C on the ls command. But if you, for instance, run your program, which might run for a while, you can use Control-C. I can demonstrate that by doing the sleep command. A sleep command basically does nothing. It just waits, in this case, 10 seconds, and then I'm allowed to type something new again. So when I press enter, I can't do anything now anymore. I have to wait 10 seconds before it will finish. But if I just want to cancel this, I can use Control-C. So then you see this notation over here. That meant that I press Control-C, and then it just aborts this command that was running, and now I can type something new. So that can sometimes be convenient if you want to stop something. And then copy-paste, because that's not Control-C. You have to use something else. Most easiest way, I think, is to just select it and then use the right mouse button. Then you will see copy and paste. But with MobaXterm, I think you can also use Control-Insert. So let's try that, Control-Insert, and then Shift-Insert to paste. Then it will paste that same text here. So it's a bit getting used to that you don't have to use Control-C, Control-V. But, well, you can use the right mouse button or Control-Insert, Shift-Insert. Redirecting output. That basically means that you can store the output of commands that you're running inside a text file. So for instance, if you want to do an echo and you don't want to print it to the screen, but you want to save it to a file, you can use this greater than symbol. That basically means all the output produced by this command, don't print it to my screen, but print it to this file with this given name. You can also append it to a given file, then you have to use 2 of those greater than symbols. And you can do it the other way. If a program wants to read in some input, you can let it read in from a text file instead of typing the values. Not lots of programs where you can use this. Often you can just pass in the file name, and then it will automatically read in the file. So I'm not going to show you how that works now. Then environment variables. those are some kind of variables which either are set by the system for you, or you can even set them yourself. I'm not going to explain the latter for now. I will just show you the ones that are set by the system. So for instance, $home and $user, those are variables that are being set by any Linux system, and they contain the location to your home directory. So if you would run this and you press enter, basically what the system does, it will look up that variable and replace the variable by the actual value, which is then the value, basically the path to your home directory. Nope. And the same for $user, that always contains your username. So if you have to use your username in some script, for instance, you can use $user instead of typing it out full. Because if you ever want to run your script on a different machine where you maybe have a different username, then it's more portable if you use this variable, because then it will automatically work on the other system. And otherwise you will have to replace all the instances of where you typed your real username in that script by your new username on the other machine where you're working on. So if you use the variable, you can much more easily transfer your script to different machines. So you have to speed up a bit because I'm running a bit late. So are there any questions so far about this particular part, about editing, about all these different commands? Otherwise I will continue with the part about editing. Don't see any questions. Okay, then I will continue. I see that animation got lost a bit here in the conversion to PowerPoint. But the first way to edit a file, which I want to show you, is with MobaXterm. So I will just demonstrate it here and show you how it looks like in real. Suppose again I want to edit this current files.txt, which I have already opened before. You can try to double click because it will recognize due to the .txt here that this is a text file. But if you don't use .txt, it's often safer to use the right mouse button and tell the system to open this with the text editor. And MobaXterm has a text editor built in. It's not the most powerful text editor that you can think of, but for most of the basic stuff, it's well, quite okay. So we can also search and replace, for instance, and do stuff like that. So if you want to make some quick changes to a file, this is a very easy way to do this. So you can just start typing here, and I can add some text over here at the beginning of the file. And when you're done, this asterisk here basically means you've changed the file. So if I now close it, it will detect that the file was changed, and it will ask me, do you want to save it? And what it basically did in the meantime, because this file was located on the cluster, but you can't directly edit it on the cluster because you're using this graphical interface. So what it has done in the meantime is copy the file to your local computer. So that's why you see this Windows path over here, while this file was located on the Linux Peregrine cluster. But it made a copy on my local machine, which it opened in this text editor. And now it says, okay, do you want to save the file? And if I press yes, it will also ask, okay, now you've saved it, but do you want to copy this saved and modified version back to Peregrine? Well, in most cases you want that, so you could even click this auto save button, then it will always just copy it back to Peregrine or the UMCG cluster or whatever system you're working on. But if you don't use that one and you just press yes, then the next time it's going to ask you this again. So I'm going to press yes, and then there's a short progress bar over here because it was copying the file back to Peregrine. But now it has changed the file, and if I want to verify it, I can run this head command again, and as you will see, my change is now in this file. Another thing that I will also show you right away, if you don't use the MobaXterm editor, you have to be careful with what editor you're going to use, because you can also press this button, open with ... and then you can choose any other text editor. So for instance, you can use Notepad or WordPad or whatever you have installed on your Windows machine. But you have to be careful, especially with those two. Those will most definitely kind of corrupt your text file, because those are really Windows-specific text editors. And Windows saves text files in a slightly different way than, for instance, Linux and Mac OS. And that means if you're going to use your Windows editor on a file that you've stored on the Linux cluster, you will most likely get weird issues because the file will be changed into a Windows format. If that ever happens to you, so if you accidentally use a Windows editor, you can also fix that by again opening the file with the default mobile extern text editor. And then you can, here at the top bar, you will see these three icons where this is Windows, or they call it DOS. Windows used to be based on DOS. The penguin here, that's the Linux format or Unix, and this is Mac. So in this case, the Linux button was already selected, so that means that mobile extern recognized that this was a Linux file. But if you ever have a file that you've edited with Notepad, you probably will see something like this, that this one is selected. So what you will have to do in that case, just press the penguin, press save, and close the editor, copy the file back to Peregrine, and then the file will be converted back into a Linux format. There's another editor that you can use. So if you don't want to use the graphical editor, for instance, if you have a very large text file that you want to edit and you want to make a quick edit, then with the graphical editor, as I showed you before, it's going to copy the file to your computer. And if it's let's say hundreds of megabytes that have to be copied, it will take really long before the file can finally be edited. Then it's better to use the text editor here in the terminal. And Nano is one of them. That's a quite easy to use text editor. So if I want to open the same file again, I can do Nano and then the file of the name, the name of the file. And then, as you can see, it will again open the editor, a very, very basic editor, but all the contents of the file is here again. And I can here add some more text. And typo, doesn't really matter, but do whatever I want to change to this file. But you have to be careful that you can only use the arrow keys here because it's not a graphical editor. So I can use the mouse and try clicking here, but it doesn't do anything. The cursor won't be moved by my mouse. So you cannot really use the mouse in this text editor. So in that way, it's a very, very basic one. But it allows you to make a very quick change to a file without copying it to your computer first. Now, how do I get out? Because you don't have a real menu bar like with a graphical text editor. You do have some kind of menu bar here at the bottom, where this symbol, this first symbol here, means the control key. So if I want to exit, that means I have to hold Control and then press X. And then it's going to ask me for the file name. I can just, it will ask me if I want to save the file. I can just press the Y for yes. And the file name, what already fills in the current file name. So if I don't want to change it, I can just press Enter. And then I get out of the editor and it will save the file. So it's a bit different from regular graphical text editors, but well, once you get used to this, it at least allows you to make a very quick change to a file. There are some alternatives. For instance, VI is a very popular one, but also one with a very steep learning curve. So you can do very, very powerful stuff with the VI editor, but you have to know lots of different complex keystrokes where you have to provide different combinations of keys to do the right thing. So if you want to use that, then feel free to look into it, but well, expect that it will take a while before you get all the details. This I already showed you, so if you want to convert the file back to Linux format, you can do that with those buttons. And I think that's it. So before we go to the exercises, are there any questions about all these different things that I've showed you? Yes, go ahead. You can unmute or, yeah.
Yes, can you hear me?
Yes, I can hear you.
Good. I had a more specific question about this sleep command, what you used in which specific case would you use it?
There are not a lot of very good use cases where you could use it, except if you want to run something and, for instance, some program has to start up and you have to wait for a while, then even then it's quite tricky, but sometimes you want to run something in the background. You want to start some task in the background, and you have to wait, for instance, a few seconds before that really starts up. Then you could put in a sleep command to wait a specific number of seconds. But in lots of cases, you don't really need it. It's just, I now use it for demonstration purposes, but I can't think of any use case I've recently used myself where I really needed the sleep command, except very complex ones. So
yeah, thanks. That was just a new one. That's why I was wondering.
Yeah, okay. Yes, Loes.
Yeah, so I was wondering, is there a way to copy and paste while editing text in with the nano command?
Yes, I think I didn't show that. I can go back to nano. Here it is. So if I open it again, I said you cannot use the mouse. There's some exception indeed for copying text. So if I want to copy this, I can copy it, and now I can paste it, but it will paste it where my text cursor here is located. So even if I right click, let's say here at the bottom right somewhere, if I now press paste, it's going to paste it where my text cursor was located. So that's how you can copy paste with the mouse, but that's about it what you can do with the mouse.
Okay, thank you.
Okay. So if there are no more questions, you can try and do some stuff yourself. Let's go to the exercise slide. So I think you can find all the material on Nestor. I think Ilya has put everything that you need on the Nestor page. So both the exercises and the input files that you will need for those exercises, and even the solutions to the exercises, you can all find them there. If you have a Windows machine, you can just go to this page and download MobiXterm. If you have a Linux machine or Mac OS, you can just use the terminal that you already have on those systems, and then you need the SSH command. And I think you're supposed to do them on Gearshift. If you don't have an account there yet, I can't really help you, but I guess Peter and Ilya can help you with setting up the account. But if you run into any other issues during the exercises, because they're based on the Peregrine course exercises, then I can definitely help you. But if it's really a specific Gearshift issue, then I will ask you to ask Peter and Ilya, because they know more about the Gearshift details. So over here it's being mentioned, what if you need help? So you can either just put it in the chat if it's a short question, but if you need some more help, we can put you in a breakout session with one of us, and we can just speak more privately, or you can even share your screen if you want to. So then just raise your hand or send us a message if you need some more help. So I think that's it for now. So you can try working on those exercises, and again, let us know if you have a question. And otherwise, we will continue around 3 o'clock with the second part of the course.